Hello students, this is Sudeep Yadav from Spectrum Chemistry. And students, if you are first time visiting to my channel, so please like and subscribe my channel and press the bell icon to get a best explanation of NCERT book, class 10th, subject science. And in science, we will discuss chemistry. And students, today in this video, we are going to discuss the second part of this chapter, that is carbon and its compounds, and the topic which we are going to discuss today, that is properties of carbon. So let's see students, what are the important properties of the carbon. Let's see. Number first, allotropes. This is very important. Allotropes, what is the allotropes? First of all, we have to know about that. What are the allotropes? So let's see. Allotropes of carbon, different forms of an element that has same chemical properties, means element will be same as well as the chemical properties will be same also, but its form will be different. Okay, there will be the different forms of the same element, but properties, that is the chemical properties, will be same. Okay, but different in the physical properties. Okay, so means physical properties may be vary, but chemical properties will be same. Okay, so these are known as the allotropes. These elements are known as a allotrope. These are the allotropes. Okay, there are three allotropes of the carbon, that is diamond, graphite and fullerene. So let's see what is allotropy. This is a property. Okay, allotropy, the phenomena in which the element exists in two or more different physical states with the similar chemical properties are called the allotropy. So means this is the allotropy. Now let's see students, what are the three important forms of the allotropic forms of the carbon. So number first, that is the diamond. Diamond exists as a three-dimensional network with the strong carbon-carbon bond, covalent bond. That is, diamond is hard in nature with high melting point. It shines in presence of light and it is a bad conductor of the electricity because carbon is a non-metal. The most common use of the diamond is in making the jewelry. It is also used in cutting and drilling the tools. Okay, so this is the diamond and its structure is very specific. This is the 3D structure where carbon are arranged in the tetrahedral arrangement. There is arrangement of the carbon, that is a tetrahedral. Okay, and this structure is a very specific. Okay, so this is the diamond structure you can see in this figure. Okay, now second one is the graphite. Graphite is made from weak van der Waals force of attraction, means graphite is existing in the form of the layers. Okay, and in between these layers there is a force of attraction is existing, that is known as the van der Waals force of attraction. Each carbon atom is bonded with the other three carbon atoms in order to form hexagonal ring, and this is the 2D arrangement of the carbon. But in case of the diamond, there was the 3D arrangement of the carbon. Here is a 2D arrangement of the carbon, and structure is a hexagonal planar structure. Okay, and here is only 3 valences will fulfilled by the 3 other carbon atoms. Okay, it serves as a good conductor of the heat and electricity. Why? Because due to the presence of the n extra electron, which is responsible to show the conductance of the electricity. In case of the graphite, actually only 3 valences are completing by the bonding and 1 electron is left out. Okay, and this free electron is responsible to show the conductance of the electricity. It is used as a dry lubricant for machines, parts, as well as it is used in lead pencils. Okay, so this is the graphite. Now fullerene, it is a hollow linkage which exists in the form of a sphere. You can see in this figure there is a right hand side. In the right hand side there is a figure is given. Okay, this is the fullerene. Its structure is similar to the fullerene like the football. Okay, but along with hexagonal rings, sometimes pentagonal or the heptagonal rings are also present. So this is the very specific structure of the fullerene. And you can see here there is a, in the left hand side there is a graphite structure. Arrangement of the carbon, you can see here there is a hexagonal planar structure, and each and every carbon atom is completing its 3 valencies, and there is a left 1 valency, and this valenced electron is responsible to show the conductance of the electricity. And this is the 2D arrangement of the carbon in case of the graphite. Okay, so here is the structures of the graphite and the fullerene. Now, versatile nature of the carbon. The existence of such a large number of the organic compounds is due to the following nature of the carbon, that is also known as a versatile nature of the carbon, that is catenation, and second one is a tetravalent nature. So let's see first, that is catenation. The linkage of the atoms of the same elements to form a longer chain is called the catenation. And this kind of the behavior, this kind of the nature having only the 2 elements, that is the carbon and the silicon. Both can form a long chain compounds, both having the catenation property. Okay, so the linkage of the atoms of the same elements to form longer chain is called the catenation. So that's the reason behind it. You can see the huge chain, the huge complex compounds of the carbon like the lipids, like the carbohydrate structures, like the starch, cellulose. Okay, so these, in all these you can see there is a huge complex structure of the carbon is existing, and there is a long carbon chain is existing due to the catenation. Carbon has unique property to form the bonds with other atoms of the carbon, forming a long chain because of the property of catenation. Carbon forms straight chain, branched chain, cyclic rings. In addition to this, carbon atoms can be linked by single, double or triple bonds. So this is a very versatile nature of the carbon. Okay, now tetravalency of the carbon. This is another specific thing regarding the carbon, about the carbon, that is carbon has a 4 electrons in its outermost orbit. This means carbon has 4 valency electrons. Because of this, carbon is called tetravalent. Second point, because of 4 valency, carbon can form bond with the 4 other carbon atoms or atoms of other monovalent elements. And carbon forms covalent bonds which are very strong. On the other hand, atom of carbon has small size. This makes compounds of the carbon exceptionally stable. So here 2 and 3 main things which are responsible, which are due to which carbon is showing the specific nature, that is the versatile nature of the carbon. There is a number first, size of the carbon, second, valency of the carbon. Okay, so here we have discussed all the things. So I hope students you must have enjoyed this video. So thank you students.